Okay, so I already prefaced this as least useful question of the year. Sometimes, okay, at least useful, a little grain of salt there, because sometimes math books make up questions that are good for you to practice your math, but in real life are like, yeah, this is useless. Okay, like let's read this question. Clara and 3 friends were born on March 11th. First of all, yeah, like that's gonna happen. Okay. Leslie is 5 years younger than Clara. You might know that. That makes sense. Mike is 2 years younger than Clara. You probably know that. And Thomas, 3 years older. These are all things you probably know, right? On March 11th, 2011, you do not know how old Clara is, but somehow you have the knowledge that if you multiplied all their ages together, it would be exactly 61,136 more than if you had added all their ages together. How old is Clara? You ask her, right? This is the answer to the question. Clara, how old are you? If Clara's one of those people that is like, oh, I don't want to tell you my age, I'm still 29, like, right? Go to Thomas, he's younger, he'll tell you. And then you can figure out the rest. Like that's the way that real life, this is how you would solve this question. But it is designed for us to do math work, and that's going to be useful. But in real life, you would never have to solve it. And like, who would know? Like, I have no idea how Clara is. Oh, but I heard that if you multiply all their ages together, 61,136 greater than their sum. Okay, so, but if we're practicing the math, which is a good exercise, everybody's compared to Clara. So we'll make Clara X years old. That makes sense. Well, what does that mean? Leslie, she's going to be X minus 5. Mike, he's 2 years younger. He's going to be X minus 2. And Thomas is older. Oh yeah, Thomas is older. He might not say either, but you go to Mike. Mike will tell you. Or even Leslie, 5 years younger. She might tell you. X plus 3. Okay. And we have to make an equation. So they give us this convoluted, I'm going to highlight it here. There we go. They give us this comparison. There's a product on one side and a sum on the other. So I'm going to write it out with words. I got a product on one side, sum on the other. They're obviously not equal. The product is much bigger. In order to make them equal, we have to put the 61,136 on a side. Does it make sense? The product was a lot bigger than the sum. So in order to make them equal, we'll have to add that 61,136 to the right side. So this is me just thinking about what that sentence means. Now what's product? That's multiplication. Now I can do the algebra. I'm going to have to do this times this, times this, times that. That's my product. Sum. If I added these all up in my head, you see that you would get 4 x's. If I added the numbers minus 7 plus 3 minus 4, that's the sum. And so we get this big equation. And we need to solve it. Okay? At this point, if you've got a big equation on one side equal to another big equation on the other, the method that I think is the easiest is either in your graphing calculator or in Desmos, make 2 equations. In your graphing calculator, you're going to make one equation in y1, the other equation in y2, and where those 2 equations cross will be our answer. So I'm going to go to my calculator right now. I'm going to go to y equals, clear out what we had from before. One side was x minus, oops, not that, minus 2. X minus 5. And x plus 3. X x minus 5, x minus 2, x plus 3. And on the other side, 4x minus 4 plus this. You could combine those like terms if you wanted to, but you don't. You can also just write it exactly as you see it. You want to do 4x minus 4 plus 61, 136. You could write it both like this. And on my graphing calculator, it's color-coded, so I'm going to draw a blue graph. I'm going to draw a red graph, and I need to find out where those two graphs intersect. Now, chances are, if you're on a standard window and you're seeing from 10 to 10, I'm going to just do that. You'll see it like almost nothing. I see the blue graph. I don't see the red graph at all. Sometimes we have to take things that we already know and apply them. Do you see that the red graph is a line? If you combine those like terms, you would get 4x plus 61,132. It would have a slope of 4, meaning that it's going up from left to right, and a y-intercept of 61,132. Are you surprised that when I went up to 10 that I did not see that 61,132? So I'm going to go to my mode. I need to see 61,000. Maybe I'll go to 70,000. Does that give me enough to see my red graph? It does. I still see my blue graph. You see that they look like they're going to cross over to the right. Okay. I'm also going to use some knowledge about people. They are not usually negative H's. Okay. Next thing, I don't think they'll go over 100. So if I go to 100, that seems reasonable. Now when I hit graph, do the two graphs cross? Yes. And when I want to solve anything on a graph, second trace, they have an intersect button. Where do they intersect? So I'm going to go to number 5, push enter. On Desmos, you just click on it and that dot just appears like, you probably want to find this one, right? And you're like, yeah, that's the one I can just click on. So Desmos is super easy. But on the intersects one, it says, click on your first curve. You say, okay, push enter. On your second one, okay, push enter. You want to guess? I think it's going to be there. Yes! And the answer is 17. So now we know that X is 17 years. So I want to figure out all these. Clara is 17. Leslie's 12. Mike is 15. He would have told you how old he is. And Thomas is 20. So not too crazy as a result. Okay, now both of these word problems had elements that required a graphing calculator or decimal. So you won't see that on the exam, but they could say, could you set up the equation? Right? The setup of the equation would be something that could be asked. And I think you have space on, here, I'll end this video. Oh, I forgot to give you questions on the last one too, right? This one, you can circle questions 7 and 8. And question number 1, you could have circled questions, well, here, 3, 4, 5, and 6, and 9 and 10. So basically 3 to 10, you can circle all those questions for 1 and 2.